What I'd like to do today is just to take you through mathematics and science and show you how they can all fit together in a single, consistent framework. We don't have that at the minute. We know we don't because we've got the standard model which sits underneath the periodic table, and we've got two rows of that model correct. And we know they're correct because they're symmetrical and predictive. If you've got a space missing with nothing in it, you go to the Large Hadron Collider, you know that you're going to find something to go in that space. But the rest of the standard model doesn't work. It's just fitted together ad hoc. And it doesn't have gravity. It only has the atomic parts of physics. So we know it's wrong. And then there's all the unpredictable parts of physics. Physics is by definition the predictable science. But what about chemistry and biology? I can't look at a jellyfish and predict a dinosaur. I can't look at chemistry and predict the hideous macromolecules we find inside cells. So we need some way to fit all this together. Now we've got some parts correct. E equals mc squared. We've got a mathematical equation that describes the relationship between energy and matter. But space and time, that's not sorted out. It doesn't have that beautiful equation. So I'm going to make two changes, and only two, that give us a completely new perspective. And the two changes we're going to make, we're going to use what we know already works. The first thing that we know works is that when we unify things, we find that everything turns out to be two parts of the same thing. Electromagnetism, strong and weak nuclear force, which as yet aren't seen as partners. But then energy and matter. We see the same thing in mathematics. We get these partnerships between infinite and finite, irrationals and rationals, imaginaries and reals. So that's the first thing we're going to do. We're going to say the singularity is dead. Everything is a relationship. It's all relativity. So a black hole isn't just a single entity, it's a relationship between all that energy in the middle distorting the space and the space distorting the energy. I need two parts of the same thing. The second change we're going to make, we're going to look at the standard model and we're going to say that our two rows of quarks and leptons are correct. And if the two rows of matter are correct, what's making those matter into what we see as quarks and electrons and determining their behaviour is what happens outside the entity. Now that's the same principle as general relativity. It interacts with something in the environment, it changes the environment, and the environment changes what it is. So we're going to say that the space outside the entities, that space comes in three different properties. The quark has three different properties. It has charge, it has strong nuclear properties, and it has mass. The electron has three different properties. It has charge, it has weak nuclear properties, and it has mass. So I need three different properties from the space outside to cause the entities to behave as they do. Now making those two changes gives me a little chart here where all the parts that sit underneath the periodic table, the parts that build the periodic table, can fit together in one consistent pattern. And you see we've now got the atomic forces and gravity sitting together. So here's how it works. Here's the quark. So this is the part of the standard model we've got correct. But this is something called a supersymmetric model. Now in symmetry, what you've got here is reflected in what you've got here. But in supersymmetry, everything is flipped about and reflected. So what you have in the fermions happens in the bosons. So let's show you how that supersymmetric model fits here. If I've got the charge on the quarks symmetric, the charge on the leptons is asymmetric. I've got three different generations of matter. Now that's always been the problem. Why should we have three different generations of matter. Now I've got an answer. If I put this entity in this space, I get a quark. But if I put this entity in this space, I get something different. And the same entity in this space, I get something different. I get a quark which has charge, strong force and mass. But that means that I'm also going to get all the other parts in the other parts of space. So I get 3 generations of matter and I can create strong, strange and charmed quarks, top and bottom quarks. But they disappear after I've created them. We've just got one kind of matter up here. So I've got 3 kinds of space. Electron space, electromagnetic space, which gives electromagnetic charge. Now you also see that mathematics fits in the same pattern. I get symmetrical mathematical patterns. Now, positive and negative is not physics. There are mathematical aspects of physical units, units of energy, which you cannot distinguish unless you use mathematical aspects. So our duality, where everything is 2 parts of the same thing, shows up between physics and mathematics. No matter where you look in physics, you always find I get 2 descriptions. Even if I go right down to the base units, the Planck units, I get mathematical aspects, 2 pi and 1, are little values of energy. Now, when I look at this, I've got the electrons and the neutrino, which are asymmetrical, and here, just putting these entities in this space gives me these forces. So now I've got forces coming in pairs, and I get 3, 3, 3, each one paired off, every one in pairs. Now that's a relationship between the numbers 2 and 3, which are the first prime numbers. And we've known for a long time that all of mathematics is based upon the prime numbers at the base, the randomness at the base, leading to the order of the composite numbers it builds. So I've got randomness, uncertainty principle, so it shows up in mathematics and physics underneath everything else. I've got 3 pairs of forces, gravity and its partner, the cosmological constant, which is put into the equations by Einstein to stop the universe collapsing itself under gravity. Now let's just show you how numbers and forces come out in the same pattern. I get positive real numbers, which make matter. I get negative real numbers. So I've got strong and weak. For each symmetry, there's a corresponding asymmetry. So I've now got different kinds of space, electromagnetic space, gravitational space, and then strong and weak particles which interact with strong and weak space. The strong and weak particles, they don't have fields, they don't act over distance, but they're interacting with the space outside. So I get a complete symmetry between the way that numbers fit together and the way that the forces fit together. So over here I've got the photon, which is much, much less energy. So that's E equals mc squared, the relationship between this half of electromagnetic space and this half. So up here I've got the electromagnetic spectrum, and here the space giving charge to this matter, which can be individual, charge, or as a field, collective. Down here, the minus imaginary numbers of space. I must have real and imaginary numbers, the real parts, the matter and the light which I interact with directly, and the imaginary parts, the space which I interact with indirectly and only see the consequences of. I've got strong space, electromagnetic space, weak space, gravitational space, and 2 parts, strong and weak, strong and weak, strong and weak. Asymmetry and symmetry. And that gives me a part of space here which has not been considered before. So if I have symmetry between the gravitational field, I've got mass as the individual, and then it just makes everything try and collapse down to a point. The opposite must happen in this kind of space, and that's what we see as dark energy, the cosmological constant. This is a gradient trying to go in, just like a bubble in the bath, where you've got a gradient, a gravitational gradient, the bubble goes in the other direction. So that's going to make this kind of space go out. Now this is weak, much weaker than this, weak and strong. So what I'm going to see here, very, very weak interactions. And there's lots of interactions here and particles which we've just not taken into account before. So there's a lot of the universe is missing. There's dark energy, and then there's all the matter there, which we've just not taken into account, the dark matter. Now you can see how it fits. I've got the symmetry up here, electromagnetism, positive and negative, leading to more and more asymmetry as I get down to the difference between matter, the real numbers, and gravitational space, the imaginary numbers, the weakest kind of numbers. So you'll see each one is the root of something above it. So minus I times minus I gives me plus I times plus I is minus 1 times minus 1 is plus 1. So I can see how it all fits together. And if I go here, those of you who are familiar with the Dirac equation, or the solutions which always fall out as matrices, I'll see a single universal principle that underpins the whole of a unified physics. Strong and weak, that's just the physical aspect of it. But I've got positive and negative aspects of it. I've got real parts, and I've got the roots of the real parts here, and imaginary parts of space. So I've got space, radiation, nuclear parts here. I've got all the parts of physics sitting together, all the relationships, strong and weak relationships, symmetrical relationships which are mathematical, and then relationships which are material and immaterial. Parts which I can experience directly, like light and matter, and parts which I cannot. And that's the roots of positive 1. So I've got everything there. I've got the roots of everything I need in a universal principle based upon the relationship between the two first prime numbers. Now, Nikola Tesla has already shown that prime numbers and the composite numbers they build are a self-organizing system of numbers. So let's have a look at the self-organizing parts of the universe which are not in physics. Physics only has the second law of thermodynamics, or entropy, which means everything becomes more disordered. So all the order I see in the universe isn't accounted for as yet by physics on its own. But a combination of physics and mathematics, no problem. If I go over here and look at the second law of thermodynamics, not just looking at the energy, but looking at the structure it builds, I've now got a dual system. I use the energy to change the structure into more and more mathematical entities. And that's the mathematics which I see building itself over here using the energy from physics. A dual system. So I don't have a contradiction between the first law, which says energy is always conserved, but doesn't tell me where, and the second law, which tells me energy is always being used up. I'm changing this into more of this until I get over here. I've got lots of this and not much energy left. Now, I want to look at the unpredictable parts of reality. So this is chemistry, biology, so physics, all predictable. But chemistry, unpredictable, biology, unpredictable. Now that must have a mathematical base, complexity, in systems like the weather, or chaotic. So straight away I see another duality between chaotic systems where the information is lost, information is mathematical, and systems which conserve information at the atomic level as DNA, at the gravitational level as repeating cycles or orbits. They conserve information. So at the gravitational level I get another system of complexity not accounted for by physics. At the atomic level I get another system of complexity not accounted for by physics. So if I have the physics and maths here, which doesn't go in repeating cycles and get feedback systems, and put it together with this mathematics, and what happens here? The same physical components that behave to the simple rules that Newton showed us start to behave to more complex rules that Poincaré showed us in the three-body problem. And it just becomes ever more complex. And that means that we can now, with this and this, the same physical components, simple behaviour, two parts, change to complex behaviour. And that throws the mind because you're looking at the same thing, you're looking at the elements, suddenly starting to use the mathematics of genetics, making DNA. You're thinking, how can that happen? It's not coming from more physics, it's coming from mathematics, which is self-organising. So when I look at that, I still haven't got time in the picture, so I need time. So we've got space now correctly sitting with matter and radiation. We're going to take time out. Time is just change. If there's no change anywhere, there's no time. Now, change is underpinned by the value of E, because E is the value of its own rate of change. Entropy, when a hot coal is cooling or radioactive decay, is described by entropy. But evolution, the evolution of chemistry, molecular evolution of biology, chaotic or complex, the evolution of the ratios between the different populations of animals, that is also underpinned by e to the x. But now I've got time in two nice symmetrical parts, negative and positive. Now that gives me a theory where I can see all the parts sitting nicely together, all the predictable parts of physics here. I add to it all the mathematics of chaos and complexity, and I get the reality we observe. A solar system with predictable parts in the orbits and unpredictable parts in the rings and belts. I get life over here from the same elements producing the physics over here. Now it's no problem, I can see how it works. And I get one little mathematical expression which shows supersymmetry. Pi squared over 6 is the relationship between prime numbers, the random parts, and the ordered numbers, the composite numbers. It's also the relationship between the infinite parts, the parts I can't count, like space, and the parts I can count. And that's called the zeta function. And it's asymmetric. On this side, I get e to the half, or the roots of e being symmetrical. So I get one little expression. The two parts of time, when I'm breaking things or making things, is caused by the relationship between matter and space. And that's the forces. I just separate space. It's negative energy and positive energy, the matter, and I get gravity in between, which just makes things happen by themselves. If you don't have mathematics and those simple forces, you don't get beautiful patterns like that. You just get patterns like that. Now this supersymmetric model doesn't just work for this. You can put all the other parts, individual parts of mathematics in, and the bosons, W and Z bosons, the colour quarks, blue ones, electrons, real parts of mathematics, +1, -1, 0, the imaginary, the transcendental and the irrational parts of mathematics, E, pi, and imaginary numbers. Some of you will know that they all sit nicely together in Euler's equations. E to the I pi equals -1, and I need 2, I must have 2 parts. E to the I pi +1 equals 0. I've got all the real parts here, and the parts which I can't count, irrational parts, imaginary parts, transcendental parts, sitting here. Now that gives me beautiful symmetry that we know underpins the whole of physics. Now, you can't just say, oh well, we use symmetry in physics. Symmetry is mathematical. And the first two things that we see generated from the non-mathematical shapes we see at the beginning of the universe, where I've just got hydrogen and space, I get more numbers and mathematical shapes. So I'm getting geometry. Now stars build the elements, and the elements create the energy that builds the star. I get 2 here, the quantum level, the gravitational level. I can't get one of these unless I get the other as well. I get both. I must have both. So now the quantum realm and the gravitational realm are seen as generating each other in a complementary partnership. Now they're seen as a contradictory partnership. So that's it. Very, very simple. An argument that tells you how simple elements like that suddenly change their behaviour and start behaving in a complex way like that, which has feedback loops and conserves information. So Brian Cox, he knows that there will be a chart like that sitting underneath the periodic table. If the periodic table is symmetrical, sequential, and all in order, the parts underneath will all be in order too. Thanks for listening. Bye bye.